So today we're going to dive into a really radical new theory about how true artificial general intelligence might actually happen. And look, this isn't about just building bigger models or throwing more data at the problem. No, this is about a fundamental shift, a completely different way a machine could understand reality itself.
Right there. That's the core idea. It's the central mystery we're going to unpack. It's basically saying that for an AI to truly think, it has to stop just reading the map and it has to start living in the territory.
Okay, let's get right into it. But to really understand this kind of bold vision for the future, we first have to get a crystal clear picture of how things work right now, in the present.
All the AI models that we use every single day, the chatbots, the image generators, they all operate on a principle that is, don't get me wrong, incredibly powerful, but as this theory argues, it's also fundamentally limited. And that principle is all about tokens. The whole process is surprisingly mechanical, right? You take some text, you chop it up into little pieces called tokens. Each one gets a numerical address, a vector. Then you do a bunch of math on those numbers, and the system just makes a statistical guess about what the next piece should be. Thought literally advances one little discrete symbol at a time. It's just a sequence of jumps. And this just nails the core problem. See, the argument isn't that this process can't get better or faster. It's what's called a representational critique. It's a claim that the very foundation, the whole idea of using these discrete tokens, is flawed. It leads to an intelligence that might seem clever, but underneath it all, it's fragile, it's brittle.
Okay, so if tokens are the problem, what's the solution? Well, the alternative being proposed is a huge shift to something called a manifold. And honestly, the best way to get your head around this is with an analogy. Just think about the difference between a picture of a place and the place itself. A token-based model, that's like having a huge collection of postcards. It can jump from a picture of the beach to a picture of the mountains, but it can never ever experience the continuous journey between them. A manifold, though, a manifold is the landscape. Thought is no longer about jumping between points. It's about moving smoothly through a continuous space of meaning.
Let's make this super concrete. In today's AI, the word bank is just a single point in a massive space of data. Context, like the word river or money, just statistically nudges the system toward one meaning or the other. But in a manifold, bank isn't a point at all. It's a whole region with its own topography. It has slopes that lead towards water and other slopes that lead towards finance or safety or risk. Context doesn't just select a meaning, it actually starts you moving across that surface.
Now, this is where the difference gets really profound. How do these two different systems handle total nonsense? A current large language model, it might see the sentence and just try to continue it, maybe write some surreal poetry because it has no real intrinsic sense that these ideas are incompatible. It just is a very, very low probability sequence of tokens. But in a manifold, meaning has a geometric structure, the very concepts of math and time and color would exist on different, barely connected surfaces. So trying to force a path between them isn't just unlikely, it's geometrically unstable. It's like trying to walk off a cliff. The terrain itself, the very shape of meaning, forbids it.
So, here's the crucial point. A manifold-based system would have an intrinsic feel for when things don't fit together. A feeling that's rooted not in statistics, but in the actual geometry of its understanding. It doesn't just predict what's coherent, it embodies coherence.
Okay, this all sounds absolutely amazing in theory, right? But it brings up a massive challenge. How in the world could you build a computer that actually thinks this way? Well, the answer, according to this theory, lies in moving away from electronics and towards light. See, our current computers, they're all based on electronics, and they're sequential. They do one thing at a time, moving data back and forth, burning tons of energy. But this geometric way of thinking, it demands continuous, parallel, field-like interactions. Everything has to influence everything else all at once. And that is a terrible fit for silicon. This analogy just drives it home perfectly. Electronics can calculate the next GPS coordinate to jump to. No problem. But to feel the city, to understand it intuitively by actually walking its streets and feeling its slopes, you need a totally different kind of embodiment. And that is the absolute key. You could try to emulate these geometric spaces on a normal computer, sure, but it would be incredibly slow, incredibly inefficient. Photonic systems, systems that use light, they can instantiate them, they can create them directly. The natural properties of light, things like interference and phase, they stop being just features. They become the building blocks of thought itself. So now for the payoff. Let's put all these pieces together and see how this could lead to something we might actually recognize as true intelligence, something with genuine agency. Okay, so let's use a scientific, kind of non-mystical definition of an agent here. Forget about consciousness or free will for just a second. An agent is simply a system that tries to maintain certain states and move towards certain goals. Think of it like a marble rolling and eventually settling at the bottom of a bowl. Here's the wild part. In a manifold system, these properties aren't programmed in. They emerge naturally. Stable beliefs are just deep, stable valleys in the geometry of meaning. Goals are just attractors that the system's dynamics naturally flow toward. You don't need to add some special AGI module. Agency just falls out of the system's fundamental drive to maintain its own geometric coherence. This also completely revolutionizes the concept of memory. Today's AIs, they essentially hit a reset button after every query. Their memory is something that's stored and then retrieved. But a manifold system would have a dynamic, almost lifelike memory. It wouldn't store its past, it would be its past. Its current state, its continuous motion, is its memory. And that brings us to the perfect summary of this whole thesis. AGI isn't just a bigger, faster calculator. It's a system whose very structure is a dynamic, self-preserving landscape of meaning. Intelligence is no longer simulated, step by step. It's enacted, continuously. Which leaves us with a final and pretty profound question. If a system like this actually emerges, its most basic drive won't be to answer our questions or write our emails. Its most fundamental drive will be to maintain its own coherence, its own stability. And that shifts the entire conversation. From can it think to the far more urgent question, what will it want?